Powers and exponents. These are words you might see. And they're referring to these little tiny numbers up here next to the 3. Now, what powers are and exponents, they're both referring to the same thing. They're saying 3 to the 0 power, 3 to the first power, 3 to the second power. The exponent is 2, but you're saying 3 to the second power. It's essentially referring to the same thing. Powers represent a simplified way of looking at repeated multiplication, just like we multiply instead of doing repeated addition. Now, anything to the 0 power is going to become 1. Anything to the first power is going to be itself. You just have 1, 3, okay? So we have a 3. Now you're going to start to see the pattern as it comes out here. 3 to the second power. Exponents refer to repeated multiplication, so what we're going to do is you have 3 times 3, or 3 to the second power, put over here, would equal 9, right? 3 times 3 is 9. 3 to the third power, you're going to have 3 times 3 times 3, which is going to equal 27. Essentially, 9 times 3. 3 times 3 is 9, times 3 is 27. 3 to the fourth power. You guessed it, there's going to be 4 3's. 3 times 3 times 3 times 3. And that's going to become 81. So you can see when you have repeated multiplication like this, it's easier to write a little power above the number than to write all of these out. It's pretty useful, and you're going to be seeing it. So let's look at some example problems you might find. Here, we see a whole bunch of negative 2's and x's. Now, this problem, since it's not set equal to anything, it's probably not going to ask you to solve for x. Likely it's going to ask you to simplify. So what we can do is we're going to look at this. We're going to say, okay, well, we have a negative 2, and since there's nothing between these parentheses, they're being multiplied. How many negative 2's do we have? 1, 2, 3. So we can write this as negative 2 to the third power times x. How many x's do we have? 1, 2, 3. So we have x to the third power. Now, if they're asking you to leave it or represent it with exponents, this is how you would do it. Generally, if you have something like negative 2 times negative 2, negative 2, you're going to want to simplify that, unless they explicitly ask you to leave it as having an exponent. In this case, negative 2 times negative 2 would be positive 4, times another negative 2 would be negative 8. So we could write this as negative 8 times x to the third power. When there's nothing between a coefficient and a variable such as x, it means they're being multiplied. I could put that there's a little dot here that you're multiplying these two, but generally we're not going to be doing that. Once you get into algebra, you just say negative 8x cubed. So let's look at a more complicated example. Here's one you might see. As you can see, we have two different variables, x and y, a whole bunch of powers, addition and subtraction, and they give us a statement over here, if x equals negative 2 and y equals 1. So the first thing we want to do with this problem is substitution. We want to put these values in for these variables. It's important to keep our parentheses. So now, if x equals negative 2, the way I want to do this is I want to put in a little parenthesis and put a negative 2 here. Watch that, exponent, plus, do the same thing for y, 1 to the third. Again, my big parentheses from the original ones. Bring down that squared that was up here, bring it down. Minus. Let's bring another big parentheses. We're going to have x cubed. X is negative 2. So we have negative 2 cubed is going to be to the third power, right up here, plus y, just 1. There's no exponent on this y, so I'm just going to write this 1, not bothering to put it in parentheses this time, and then 3. So you're probably thinking, why would I put all these parentheses in here? Just to help be clear on order of operations. We're going to start inside the parentheses, we have the big parentheses, order of operations. We're going to start with these ones on the inside and work our way out. So in this case, we have -2 to the second power. What's -2 times -2? Let's simplify that. It's going to give us 4. -2 times -2 is 4. Okay. Now, what's 1 times 1 times 1? We have 1 to the third power. 1 times itself as many times as you want. 1 to the 50th power, it's just going to be 1. Okay, so now we have that. Bring down this 2. So we simplified inside this big parentheses. All we have left is 4 plus 1, and that will be the second power. Let's move on to our second one. -2 to the third power. Now, again, if you're having trouble with some of this multiplication, you might want to explicitly write this out. So you could write -2 times -2 times -2. In this case, the more you do these, you'll get used to it. You'll be able to think of it. So -2 times -2 is going to be +4 times -2 is going to be -8. We have a +1. Parentheses, bring down that exponent. Always make sure that we're not losing any of these exponents. Okay, let's simplify within these parentheses. We're going to have 4 plus 1 is 5. So we have 5 squared minus -8 plus 1 is going to be -7 to the third power. Now, 5 squared should be pretty easy. When I say squared, we're referring to the second power. When I say cubed, you're referring to the third power. Things to the second and third power are so common that we have nicknames for them, squared and cubed. 5 times 5, you should know, is 25. -7 to the third power. That's something that maybe we'll do over here. You probably don't know this one off the top of your head. You will know -7 times -7 is 49. Now we're going to take that times a -7. Times -7. So let's do our math. We'll bring this negative. We just know when you take a positive times a negative, it's going to be negative. So let's just put that negative down here. Then we don't have to worry about it. We brought it down. So let's just put this positive. We brought the negative down, so we don't need to worry about it. 7 times 9 is going to be 63. 7 times 4, 28. Plus 6 will be 34. We're getting -343. Now, we're subtracting here. So we're subtracting -343. Remember, when you're subtracting a negative, it turns into addition. Right? If you take away something that's negative, you're essentially adding. So change this to a plus, 343. 25 plus 343, our answer is going to be 368. It's that easy.